Dear students, welcome to ECA1 class. Today we will discuss maximum power transfer theorem. When designing a circuit, it is often important to answer few questions. Number one is what load should be able to a system to ensure that the load is receiving maximum power from the system or not, or for a particular load what condition should be imposed on the source to ensure that it will deliver the maximum power available. Fortunately, the process of finding the load that will receive maximum power from a particular system is quite straightforward due to maximum power transfer theorem, which states that the load will receive maximum power from a network when its resistance is exactly equal to the Thevenin resistance of the network applied to the load. So we say that when load resistor is equal to the Thevenin resistance, it means the maximum power is delivered. From the figure you will see that this shaded region is basically Thevenin equivalent circuit in which this resistor is basically R Thevenin. When this R Thevenin is equal to that load resistor, we say that the maximum power is being delivered. From this figure you will see that this is simple series circuit. So when we calculate the current of the series circuit, or the current from the load resistor is equal to total voltage, which is E Thevenin, divided by total resistance of the circuit. Total resistance of the circuit is basically R Thevenin and RL. So when we are dealing with the maximum power transfer, so RL is equal to R Thevenin, so we can replace it E Thevenin divided by R Thevenin plus R Thevenin. So current from the load resistor is basically equal to total voltage divided by 2 times of the R Thevenin. Now using the power relation and substitute the values, we will get PL is equal to IL square into RL, which is equal to E Thevenin divided by 2 R Thevenin whole square multiplied by R Thevenin, because RL is equal to R Thevenin, which is equal to E Thevenin square into R Thevenin divided by 4 into R Thevenin square. This R Thevenin will be cancelled out with that square term. So the load power of the load is equal to E Thevenin square divided by 4 times of the R Thevenin. This is basically the maximum power delivered to the load resistor. Let us take an example to verify that the maximum power is delivered when R Thevenin is equal to load resistor. E Thevenin is equal to 60 volt, R Thevenin is equal to 9 volt, and load resistor is basically a variable load resistor. So when we find the value of the current, which is equal to E Thevenin divided by R Thevenin plus RL, substituting the value of E Thevenin and R Thevenin, we get 60 volt divided by 9 ohm plus RL. RL is basically a variable resistor. So VL is equal to RL into E Thevenin divided by RL plus R Thevenin, which is equal to RL into 60 divided by RL plus R Thevenin. Now the power is equal to IL square into RL, which is equal to 60 volt divided by 9 ohm plus RL whole square into RL, which is equal to 3600 RL divided by 9 plus RL whole square. Now we substitute the values of RL randomly and we will see that we have this thing. Now you will see that RL, when we vary RL 0.1, 0.2, 0.5, 1, 2, 3, 4 up to 1000 ohm, the power is changing. Now at this point, when RL is equal to R Thevenin, which is equal to 9 ohm, you will see that 100 watt power is delivered. From this graph you will see that if we go if we change the RL greater than the R Thevenin, the power is decreasing. If we decrease the value of RL from R Thevenin, the power is also decreased. So when R Thevenin is equal to RL, the maximum power is delivered at that time. The operating frequency is defined as the ratio of the power delivered to the load PL to the power delivered by the source. So percentage efficiency is equal to PL, power delivered to the load, divided by power delivered by the source, into 100. When R Thevenin is equal to RL, we will see that the efficiency is equal to IL square divided by RL divided by IL square into RT into 100. RL divided by RT, because IL square will be cancelled out. We will get R Thevenin divided by R Thevenin plus R Thevenin. So when we substitute the value, we simplify this equation, we will get the percentage efficiency of operating efficiency for maximum power delivered. The maximum power theorem is equal to 50%. So this is the maximum efficiency for maximum power transfer theorem. That's all for today. If you have any question, comment in comment box. Thank you very much.